Well, good evening, ladies and gentlemen. I hope everyone is well. Um, I guess the first thing that I need to talk about, and something that you may be curious about, I hope you all got an email that I sent out about a test that I'm going to give Thursday morning. This will be as an email sent to you, and uh, it will be due at 7 p.m. on Friday. 7 p.m. on Friday. Now, that's going to be two things there. One is it's going to let us answer any questions that you may have Thursday evening. Now, I can't guarantee to give you answers, but hopefully, if there's something that needs to be clarified, I'll try to do that. And it is going to be a short answer. There are some um, things in there that you're going to have to provide lists. There's things you're going to have to do to interpret. Now, I know that some of you do not have textbooks. I don't know how many don't have textbooks. Um, I don't know what I can do to help that matter. I have a couple here at home. I need, of course, one for me. I have one more, and I hate to say that, pick out someone that needs it. Now, they're possibly going to be opening up the school temporarily. Um, you might call the school and talk to someone and see if there is a possibility. I can't tell you one way or the other. They're beginning to relax a few things. Next week, I think the relaxing will be even more. We'll see. We'll see. I can't. It's not hurt. It doesn't hurt anything to try. But along with that test on Thursday morning, I am also working on some supplemental material that will include some figures. It'll include um, things that aren't included in the DNA and RNA handout that I gave you, the review sheet that you've done. Most of you have done that, and you are doing a good job on these assignments. And unless I tell you otherwise, every time that I email back to you and say you got it, good job, thank you. Uh, I put those down as 100 in my grade book. They're quiz grades. This is the first test besides the graph part of your virus assignment. That is a test grade. And the ones that have turned those in have done a pretty good job on those. Again, I'm uh, pretty lenient with those. I know that that's been pretty hard for some of you to get all that material together. But again, the ones I've seen have been pretty good. Now, one thing that I am going to do, they had us post grades, and I'm going to go ahead and continue on in the third 9 weeks, and I will be putting the test grade that you have, or that you're going to get from the test on Thursday on that. So if you have a parent view, um, maybe I can check on with Mr. Harris and see what his suggestion would be there. But parent view, I'm going to try to put it on there by, if I get it back Friday evening, I'm going to try to get it on there by the end of the weekend, and so that you can see what grade you made. There should be no excuse for not making a good grade. If you don't make a good grade, it simply means that you just simply haven't tried, because you're going to have answers in the review sheet that you've got, have already done, and also the supplemental material that I'm going to provide for you Thursday morning. Again, I understand folks don't have books. You can use other books. The only thing I am stipulating, really two things I'm stipulating, is one, that you cannot look up answers on the internet. And I'm going to have to trust you on this. And I feel pretty good about doing that. You're a good bunch, and I don't feel too bad about trying to trust you on that. And of course, not to ask any of your friends what their answers are. And um, I think most the only reason that you would make a less than 90s or 100 would be simply because you didn't answer a question, or you just didn't try. If you look things up like you should on your handout, and you read the handouts and you read the supplemental material that I'm going to provide you, I think you're going to find. In fact, I'm going to tailor the test so that I'm sure those things are there. Now, sure as I say that, we'll have probably Caden and Michaela will find something that is not on the handouts that I give you or the supplemental material. And if that happens, then we'll just do what we've always done and try to modify, omit a section if we have to, omit a grade, a test if we have to, omit a question if we have to see what goes on there. We'll try to do our best. I'll try to make it pretty much tailor made there. Um, I hope that is enough information for you. Like I say again, you don't have to listen to these just as I'm giving them. You can listen to them at another time. Though, if you have questions, there's of course there is the part that you can make comments or you can ask questions, and I'll be glad to try to answer those as best I can. Going to pick up talking a little bit more about the handout on ecology. Some of you have already done that, and that's great. I think uh, assign ecology assignment due tomorrow. I believe that's what I did put on there, that it is due tomorrow. I'd have to look back at my notes on that, but correct me if I'm wrong, guys. I think that is the thing that I gave you. And I hope you are all getting I hope. I have had return emails where people have said that they need me to email to another email address, and I have added those to our list. I think Lauren had me add an email address, and I think Alicia had me add an email. I hope that you're getting the questions, the sheets, review sheets, and everything. If you're, it's hard to say if you're not, give me an email. But if you know of someone, y'all pretty much communicate with each other. If you know someone who is not getting things, have them call me at my house here. Not in the next 30 minutes, but sometime maybe tomorrow. Um, Call at 261 2635. And if they've got another email address that I need to be sending things to, like I say, I've added probably 4 or 5 in the last week or two that people have said, hey, I need to get it in this email address. And I don't mind doing that at all. But just let me know. Let me know what I need to do, and I'll try to get it to you as best I can. Like I say, the restrictions may relax a little bit as time goes on. There's even talk about a senior parade. Just to give you some things about what we've been discussing in faculty meetings. You probably know these things before I do. You always seem to know things before I do. So there's that, and the gift bags. We've talked about those. We've talked about possibilities of some kind of graduation in July. Um, there's a lot of things that we're trying to do to especially address the fact that the seniors are missing so much, and it just breaks my heart to all the seniors that they have missed so much. And I tell you guys, just keep on. Look, you've got um, great chapters in your lives coming up. I'm almost sure. Okay, now to get into ecology. Ecology is the interaction of organisms with their environment. Now, we're mostly dealing with abiotic. Abiotic, remember again, is non-living. So we're talking about the atmosphere, the lithosphere, and the hydrosphere. And we focus mostly on the atmosphere, and we talked about what is the uh, latitude of the equator. and it is 0 degrees latitude. So if I go north of the equator, 10 degrees north would be a latitude that is north of the equator. If I go 10 degrees south, then that would be a latitude that is south of the equator. The Greenwich, I remember reading someone's answer to uh, that question. There was a question that asked about that. And they said something like Greenwood, um, and it's Greenwich, and it's in England. And the British Empire basically said, "Hey, this is going to be 0 degrees longitude right here." Now, when it got to the Pacific, the international date line is 0 degrees longitude. And so if I am going from Greenwich, England toward the United States, the longitude would be, say, like 10 degrees longitude, 10 degrees east longitude. The numbers get more and more and more and more and more. Then that gets closer to the international date line that is in the Pacific, where it gets to 180 and then flip goes to 0 degrees again, right there at the international date line. And then as we as we go, then continue go to the west, then the numbers tend to again increase as it goes on. A little complicated, but that's the way uh, these lines are used on maps. And many of you looked up in your phone and you said, this is not just a map class, but several things about that is as we go from 0 degrees latitude to the north, temperatures tend to get cooler, obviously, if we're going toward the Arctic. If we go 10 degrees, if we go south of the equator, as we get toward the Antarctic, again, temperatures get to be colder. And another interesting little fact there is that if we look at the equator and go about 20, 25 degrees north and south of the equator, if you look at a globe, and in your handout, there is actually a map, a figure that shows this kind of thing, and you'll notice that there are deserts there. Now, the reason for that is that at the equator, uh, the sun has pretty much direct rays heating up the atmosphere at the equator. And as the atmosphere, as the air warms, it like air does when it warms, it rises. And then it rises. If you keep going up and up and up and up in altitude, it gets cooler. And so the air rises, gets cooler, and its relative humidity increases as the air mass gets cooler. Eventually, it gets to 100%, and over 100%, you have precipitation. So you have this tremendous amount of precipitation at the equator, and this gives us a tropical rainforest where the precipitation easily goes over 100 inches of rain a year, and temperatures are pretty much constantly warm to hot. Now, the point is then this rising air is then going to fall as it gets cooler. It can't fall directly back on the equator because it's got constantly rising air, and so it has to go to either side of the equator. And as it goes to either side, it then begins to warm up as it goes down. And this cool air mass is going down. It begins to warm up. It's already had all of its moisture taken away at the equator with the rainfall there. So as it goes down now, it's very dry. Its relative humidity is very low. And then any desert situation is where relative humidity is very low. Rainfall is probably less than 10 inches a year. And so north and south of the equator, like for example, in North Africa, you have the huge Sahara Desert. Okay, and that's about 20, 30 degrees north of the equator. And it is there because of the lack of moisture that's in the air. Also, there's a lot of things having to do with this. We're not going to get into all what we call Coriolis effect and the fact that the wind tends to curve as it falls down, and you've got all this curving wind. And early sailors knew about all this stuff. They may have not have known all the reasons why, but they knew about all this stuff. And excuse me, I need to plug in my winds work. Now, when you look at a wind is trying to correct an inequality. If you have different temperatures in different areas, then there's going to be wind. If you have different air pressures in different areas, you're going to have wind. Um, a lot of the things in this handout are things that you don't have to answer. Okay. Statements like the dew point, it gives you a definition of that. Most of the moisture that reaches us comes from the Gulf of Mexico. Cool air comes from the west and northwest. Those are all statements. You don't have to answer anything about those. One of the things that is kind of interesting here is when you have air coming in from the Pacific, it has obviously it's going to have a lot of moisture. It's just coming from over water, and it's going to have a lot of moisture. As it begins to get into the mountains, this air rises, and again, air rising tends to cool, and it is going up a mountain, and the air is cooling down, and you're going to have precipitation. So the western side of the Rockies is going to be a lot wetter than the eastern side of the Rockies. And to the west, on the western slopes of the Rockies, you have these tremendous uh, explosion of growth of forest. North, tremendous amounts of vegetation growing, plants growing, and their rainfall is in some areas well over 60 inches of rainfall a year, and in some cases going all the way up to 90 inches of rainfall a year. Portland, Oregon is a place where you've seen maybe movies or something about, and it rains a lot there, and you have a lot of vegetation. You go east of the Rockies, the eastern slopes of the Rockies are much drier. When I was fighting the fire, I was on the eastern slope of the Rockies in Idaho, and the relative humidity was routinely in the 30s or 20s, and we would in fact have rainfall in the evening, and then by the fire kept going. So this was this extremely dry conditions out there. And when you also when you go up a mountain like that, now that by the way is called the rain shadow effect. When you go up a mountain, you are obviously getting cooler and cooler and cooler and cooler and cooler. And so this coolness is reflected in the kind of vegetation that grows there. I mean, you think about Klingman's Dome in the Smokies, the highest point in the Smokies. It's above a mile in elevation, and the kind of plants that grow up there are more like what you would see in Canada than any other place in the United States. I mean, it's interesting there. And if in the Rockies, the elevation is so high in the tops of the mountains that it even gets in places like the Arctic, and you have tundra, like in a little south of the Arctic, and you have permanent ice. You remember if you've ever seen pictures of Mount St. Helens. Mount St. Helens is a mountain that exploded in 1980, and if you look at the pictures before it exploded, it was almost a perfect cone, and the top of it was permanently frozen in ice and glaciers and snow. And when it exploded, it blew up as a volcano. All that came rushing down, and had some really interesting effects. For example, you had just tremendous depositing of sediment in layers, very much like what you see in the Grand Canyon. And in fact, then when the water came after that, you know, there's plenty of YouTube videos showing this. When the water came after it, it actually carved canyons in those sediments, again looking very much like the Grand Canyon, and all in a matter of days, and which is remarkable. In fact, if you look at the uh, Spirit Lake, which is just below the mountain, a lot of trees were washed into it, and a lot of minerals were washed into that lake. and the speed with which fossilization occurred, where the wood became petrified, what we call petrified, which means basically filled with minerals, uh, was in a matter of weeks. And if you go to the petrified forest in Arizona, um, one of the things they say in the little displays there and everything, these took millions of years to form. And creationists point to Mount St. Helens a lot of times and say, hey, this is evidence that you have a wood being petrified in a matter of weeks instead of taking uh, millions and millions and millions of years. So there are very interesting things about we see around us in terms of plants. Animals, we have some very basic requirements: food, water, and shelter. And with plants, it is water, light, and minerals. When you look at something like a lake, light is very, very well defined as where as far as it goes down into the water. The place where light doesn't reach is called the aphotic zone. Photic meaning light, a meaning not, no light. The place where light does reach is the photic zone. And so it's common sense that plants requiring sunlight are going to be in the photic zone. Then, if you think of that, it's got water. It's a pond. It's a lake. It's an ocean. And so, if you're in the photic zone, then the next thing that is critical is the minerals. And in fact, what we find is if you get out into the open lakes and open ocean, the critical limiting factor for plant growth is minerals. And minerals are found basically in shallow waters. And if you have very deep waters, then the minerals are and they go down into the ocean and they're not accessible to plants. And so if you go out in a boat, for example, in off the coast of Georgia, and you say, I'm gonna go fishing. You see people bring in huge buckets of fish and coolers in there, nothing. And you get with you say, oh, this is crazy. I'm just wasting my time. You get with a guide, and the guide takes you out there, and boom, you catch fish, one after the other, one, and just fill up a big cooler full of fish. And the point is that the guy who is the guide knows where the shallow water is. You say, well, wait a minute, Mr. Witt, the oceans are very deep, and you're right. In some places they are, but in some places they're not. And they have mountains just like land does, and the mountains get close to the surface of the water, and you've got tremendous amounts of, uh, of plant life there, and fish feed on it. The Grand Banks off the coast of Nova Scotia in the North Atlantic have been fished for probably the last 300 to 400 years, and a tremendous fishery there. And the reason that and it's out in the middle of the ocean, okay? And so the reason that it is there is because under the level of the ocean, there are mountains. And the mountains are close enough to the surface that the minerals can then be in the photic zone. So again, in a aquatic ecosystem, you have light, water, and minerals. And it's light, it's aquatic ecosystem. So then probably one of the big factors is minerals. And so if you look at the drawing of the pond that is in your handout, you see the photic zone, aphotic zone, littoral zone, limnetic zone, thermocline, and so on. That the place where you have the most productivity, it's a little note that you might need to put on your paper there. The most productivity would be in the littoral zone. Why? Because there's minerals there. It's close enough to the bottom of the pond there at that point. It's close enough to the surface. You have minerals that are in the photic zone there, and you have a lot of plants. Where you have a lot of plants, you have a lot of animals. And so that would be a case where the limnetic zone, when you get on out into what's called the limnetic zone, the open ocean, the number of animals goes down because the number of plants is going down. Okay. Now, one of the terms mentioned there, number 25, is called a thermocline. There's no figures about the thermocline, but let me try to explain this to you. Thermo means temperature, and during the summer, and you can use your experience in lakes that you've seen. The water is going to heat up at the surface because the sun is shining on it, and the sun heats it up. I mean, we all say, "Well, yeah, duh, yeah, it does that." Then if you go down in the water, like an Indian boundary, if you're right on the surface, it's warmer. You go down, it gets much colder. Okay, and so if you put a probe into the water and you lower it down into the water, and the probe is a temperature probe, then it's going to be warm at the top, and as it gets closer and closer to the bottom, it's going to get colder and colder and colder and colder. Now, the thermocline is very simply defined. It's the place where the water temperature decreases the fastest. Place where the water temperature decreases the fastest. And if you're letting this probe, this temperature probe down into the water, you notice the temperature changes from, say, 68 to 67 to 66 to 65, and then boom, it goes all the way down to 60, and then 58, and then 56. That place where it has changed rapidly is the thermocline. Now, you think, well, whoop-de-doo, big deal. Well, it acts kind of like a barrier. Now, fish, of course, can swim across it. Don't misunderstand me. But fish have to have certain things too. They have to have oxygen. They like certain temperatures. Now, one of the things about cold water and warm water is cold water can hold more oxygen than warm water. And what does this tell us? Well, if you look up Tellico River and you're going fishing up there, and trout are found in Tellico River. Why? Because it's cold water. If you go on down to the Tennessee rivers, they don't like uh, where the temperature is higher like that, but they also don't get enough oxygen. Now, you measure oxygen parts per million. So what's happening here is at the thermocline, you have a division. You have warm water up here, thermocline, and then cold water down below that. So during the summer, you have this thermal stratification. Thermal stratification means temperature, stratifying means in layers, thermal stratification, and that is going to make the warm water species of fish more found in the upper regions, and then the colder water species of fish found in the areas below the thermocline. Now, and bass fishermen, for example, are very aware of this, and they will adjust the depth at which they fish based on what kind of fish they want to catch. And that is again a function of where that thermocline is. Okay. Now the thermocline disappears in the fall. Why? Because the air temperatures are getting cooler. You're no longer having the top layers of the water getting warmer. In fact, they're getting colder. And cold water sinks, warm water rises. And so again, you have what's called a turnover. And that turnover mixes the water up so that you no longer have a thermal stratification. And so therefore you have less, for example, bass tournaments in the late fall and winter than you would have in the summer. Again, because thermal stratification kind of determines where a lot of fish are in terms of what they require in temperature. Now, anybody have a question? I know that's a lot to cover. The thermocline usually occurs during the summer. Benthic is the area where there's going to be low oxygen. That's the very bottom of a lake or a pond or an ocean. That's benthic organisms. If the water is deep enough, there's not going to be light down there, so there's not going to be any plants. And they're going to have animals that are adapted to low oxygen and that are adapted in many cases to feed on what falls from above. Now, you remember Finding Nemo. that marlin goes down into the depths of the ocean, and those fish down there don't feed on plants. They feed on things, that unlucky fish that sinks down in there. They feed on that. They feed on bottom organisms, or they feed on each other. And so there's a variety of niches there. Remember, niches is the job that an organism has in an ecosystem. Now, one of the things that we use in terms of measuring um, productivity in ecosystem is what's called biomass. And so, if we were looking at a lake, the place where you would have the most biomass would be the place where it's most productive, where you have the water, the minerals, and the sunlight. And that would be in the littoral zone. Okay, where you have the least biomass would be out in the open. If you're talking about an ocean, it's open ocean. Okay. Um, Now, if we then move on to the soil, then which is the lithosphere, and this is probably the one that folks know the least about. And there is the mineral material in the soil, which makes up about 40–50% of the soil. Water is going to make up about 20–30%. Air is going to make up about 20–30%. And some folks are amazed that we have air and water and soil. And that you shouldn't be. That's the way a soil is. That's the way plants can grow in a soil like that. Now, you also have about somewhere between 0 and 10% organic matter. Now, I'm not trying to say that there's over 100%. Those numbers vary within those ranges. The more highly organic a soil is, the greater percentage of organic material. And if a soil is compacted, it's going to have less air in it. If a soil is full of water, it's going to have more water than 20–30%. For example, if there's a heavy rain, you'll notice at the school that you're crossing the breezeway going from the main building over to the gym and cafeteria. When there's a lot of rain, you'll oftentimes find a whole bunch of worms on the sidewalk there. The reason is worms breathe air, and they have to have air in the soil for them to breathe. And if the soil gets full of water, they got to go somewhere, and so they crawl out of the soil, and they'll get up on the sidewalk, get up on the surface of the ground, and that's how they survive. Then when the rain stops, and they are able to crawl back down into the soil, then they can survive down in there. I didn't go into a lot on the soils. There's more just statements there more than anything else. One of the things I did spend a lot of time on was the idea of decomposition. Decomposition is by fungus and bacteria. And there are certain conditions under which decomposition does best, which favors the fungus and the bacteria, and there are certain conditions where it's not. It's in terms of whatever is good, like pH, for example. pH of the soil, if soil is very acidic, then decomposition is very less. Like in the tundra, in the cold ecosystems of the far north and the far south, the cold is going to reduce decomposition. And also, once you reduce decomposition, you have a lot of organic matter, and organic matter mixed with water forms carbonic acid, and that's going to make the pH less. And so, in those conditions, you have a very low decomposition. Now, in places like Scotland, which is the upper end of the British Isles, there's a lot of tundra area there, and this decomposition has been so low over years and years and years and years and years and years that any grass or shrubs or things that die, the dead bodies of these plants tends to accumulate in such big layers that it's organic matter. It's like wood almost, and so they can dig it up in blocks, and for years, hundreds of years, the people of Scotland and Norway and Finland and other places where you have high up in the latitudes toward the Arctic Circle, they burned this for fuel for years and years and years. Terrible fuel. has a tremendous amount of smoke in it, and but it does burn. It's like a real low grade of coal, but it does burn. I mean, if that's all you got, that's all you got. In the desert areas, they'll oftentimes burn manure. They'll pick up the manure piles that have dried up over the years from camels and horses, and that's this dung they call. That'd be awful. Now, then you have pH. Then has to be right. The temperature has to be right for decomposition to occur, and there's fairly narrow ranges there. pH probably around 5 to maybe 7. Temperatures probably in the 40s on up into 60s, 70s, 80s. All those would tend to, the higher the temperature would tend to promote decomposition. Dryness is another thing. In Egypt, people died and they mummified them, wrapped them up, put them in tombs and everything. And certainly the act of mummification helped to preserve the bodies, but also the tremendous dryness would preserve the bodies. The Incas in South America, the Andes of the South America, the mountains of South America, also practiced this thing of having mummies, and they would go through the process of mummification, which would certainly help preserve the body, but also the extremely dry conditions in some of the higher altitudes there, and the cold. And in fact, their famous kings, they would put into a house, and this dude would be sitting there, and then when they wanted to, they'd have huge questions, national questions and everything. They'd bring him out, they'd trot him out, they'd put him in a chair and everything, bring him out with the idea that they were going to ask him questions. Now, who in the world, would ask the questions, and how would they know his answers? I have no idea. But these mummified bodies would be around for literally hundreds of years. And in the case of the pharaohs, of course, is mummified. A lot of officials were finding, that's kind of the end thing to be when you died, is to be mummified. And so um, they those would last hundreds of years, thousands of years. Now this thing tells me my connection is unstable. Please while we try reconnecting. Can y'all still hear me? Tell me if you can hear me. Just give me a thumbs up or something if I'm still getting across to you. And so, again, if this is not working, there's no sense, and I can move to another room closer to a router. Hopefully, we'll see. I'm going to stop here in just a moment. Now, we're going to have another live stream on Thursday, and y'all let me know if something is not coming through good. I got one thumbs up, so evidently we're coming through. And I'm going to try and give you a chance to ask any questions. Pass the word along that once you get this test on Thursday morning, if there is something that you want to ask a question about, you come to that our live stream Thursday evening, answer, if I can, the questions. Now, I want you to understand this test is going to have where you are going to do some writing. It's not going to be an essay test. Don't worry about that. There will probably be some. It's not going to be all true false either, which y'all probably like that. But there's going to be some true false. There's going to be yeah, McKinley, I'm in the middle of nowhere too. So hopefully this is coming across. If not, maybe you can go somewhere where it does come across better. You can watch this at any time you want to, that's for sure. But if you have any questions, then Thursday you can ask that. Now, my plan is on Thursday to begin going into a little bit more about ecology. Now, this will be stuff that's not in your handout. I'll be elaborating on some things that are in your handout, and but some things that are not. Now, in terms of testing, you're going to have this test on Thursday. Next week, you're going to have another test. Now, the one next week will be over the first set of ecology notes that you've got. uh, and you'll again be able to use those notes. Okay. The next set of notes that I'm going to give you is going to be on ecology as well. If this is on abiotic, the next set of notes is going to be on biotics. So it's going to be more dealing with living things. And then you'll have a test on that in about 2 weeks. Okay. We're going to have the last thing we're going to cover in the whole semester will be on plants. And we'll try to get into some things about flowers. We may ask you to go out in your yard and pick some flowers um, and maybe bring a stem in. You're going to look funny, I know, sitting with your computer with a leaf in front of you or a stem in front of you, and I'll try to point out some things here, and we'll have a handout on that as well. But that's going to be a little over 2 weeks. So again, coming up Thursday, you got a test, and there's a time limit on it. And the time limit is from you get it Thursday morning, and it's due at 7 o'clock on Friday, and 7 o'clock in the evening. Okay, 7 o'clock p.m. And if you don't get it in that time, if it's not date stamped at that time or before that, then you're going to have some points counted off. Okay. Um, are there any questions? Again, I appreciate y'all getting on here and watching this. Hopefully, everyone gets a chance to see it. If not, keep paying attention to your emails, guys. You're going to be getting the test, of course, on Thursday. You're going to get an email, which also is going to have some supplemental material on DNA and RNA. And that supplemental material is going to be essential to help you do well on the test. And so, if there's anyone who is not getting emails, if you know of anyone, have them call me tomorrow, 261-2635. I don't know what we can do to help you, but we'll talk it over and see what we can do. I hope y'all are well. Hope everything's going well. It looks like things are opening up a little bit. How that'll impact the school and graduation and activities, I have no idea, guys. They're going to have some meetings this coming Thursday. Principals are going to be meeting, and people from the central office. Maybe some things will come out of that. And if I'm allowed to, I will certainly pass them on to you. And I'm kind of foolish saying that because y'all probably know things before I do. But anyway, that's coming up. All right, I'll say good evening to you and wish y'all well and hope you're staying well. We'll see you. Bye.